Welcome everyone. In this video lecture, we will solve a problem based on diode, which is from the Microelectronics circuit book. And this problem is just a continuation of the last problem. So in this question, we have to sketch the output waveform. So the question is, in each of the ideal diode, all are the ideal diode based circuitry in which we are giving a input Vi having 1 kilohertz frequency and 10 volt peak. This one is 10 volt peak and this one is minus 10 volt peak and peak to peak 20 volt and sine wave. Okay. So sketch the waveform resulting at V naught. So what should be the output waveform and what is the positive and negative peak values? Okay. So in this very first question, that is our E problem. So in this case, for the positive half, for this half, okay. So now one more thing, frequency is given 1 kilohertz, okay. So time period 1 by t is f. So time period we can say 1 by frequency. So if we divide 1 by f, so if we divide 1 by f, 1 by 10 to power 3 means 10 to power minus 3, okay, second or millisecond, or simply say 1 millisecond. So this one is time period is 1 millisecond, and better to write this one is 0.5 millisecond, this point, okay. So the first half, for the first half diode D2 will be conduct, okay. So D2 will conduct for the first half in between time, say 0 to 0.5 millisecond, okay. So in between the D2 conduct 0 time 0 to 0.5 millisecond, D2 will be conduct and this will be go like this, okay. The waveform will follow this path and the same Vi will appear at V naught. Now D1 will conduct in between second phase, is in between 0.5 to 1 millisecond. In the second one, it will follow this one for the first time period. So every time it will give V naught. So input follows the output follows the input. So the output waveform, okay, the output waveform, that is our V naught by T, will be same as that of this one, okay. This one is our 1 millisecond point and 0.5 milli, this point, okay. So in this time, for the first time interval 0 to 0.5, D2 will be conduct, so it will go like this, okay. And in the second half this will be conduct. So always, and during D2 conduct, D1 will be off, okay. And during D1 conduct, D2 will be off, okay. So D2 on, okay, in this period, and in this period for the negative half, D1 will be on, okay. So input follows the, sorry, output follows the input. Simply one can write output follows the input. Very simple is that. uh, Two diodes, okay. So in the first half this one will be conducting, so this all ideal diode, so all Vi will be appear at this point. So V naught equals to Vi. In the negative half this will be D1 will be conducting, okay. So it will be in the off state, okay. So this one is the overall output response, okay. So in the next problem, this one is the problem, okay. So once again, for the first half this D1 will be conduct, okay. For the first half, this half, okay. Say 0 to, I am saying T by 2 or T, okay. So for T I am writing it 1 millisecond and T by 2 is our simply 0.5, okay. In between 0 to T by 2, in between time 0 to t by 2, positive half. Okay, so this d1 will be conduct d1, and this one is also positive one. So d1 and d2 will conduct. Okay, but d3 will be off, or we can say d1 d2 on and d3 will be off. Okay, so for the first half it will go like this. Okay, so in the very first half, this one is v naught and t. The output will be this. Okay, for the negative half, for the negative half in between time t by 2 to t, this should be t by 2 to t, and it is negative 1. So d1 will be off. Okay, reverse bias. I'm writing reverse bias, so reverse bias. So this one is open. Now this will be open. Okay, open for this case. Okay, so when it is open, so it is not a closed path, so nothing will be passed, so the output will be 0. Okay, for the another half we'll again go like this. Okay, so this one will be the output waveform. So here the v peak, okay, v peak will be 10 volt, v peak positive. Okay, and vp minus will be minus 10 volt. So in this case v peak, okay, positive one will be 10 volt, and vp negative will be 0. Okay, simple. This will be very simple problem, but we have to very careful means how we are doing. Okay, so this one is the second example. Now for the third one, okay, so in this case again I am saying this one is t by 2 and t. So this one will be conduct in the negative half. Okay, means if some negative voltage, okay, means this one is positive and negative, so this one will be forward bias. Okay, for the negative half. Okay, for the negative half I'm just putting the DC, but basically this one is a AC signal, but for the time being I am saying for the negative voltage, say plus 10 or like that, minus. Okay, so in this case in the negative half it will conduct, and during the positive half it will not conduct. So the output response v naught and t. In this case, okay, negative half, in the negative one, okay, plus or minus. Okay, so in the negative one it will conduct. Okay, for the positive one it will not conduct, so it will go like this. Okay, so here v peak, v positive peak will be 0 volt, and v peak minus will be minus 10 volt. Okay, so here we can say that d1 sorts to ground for vi greater than 0. Okay, or we can say here d1 sorts to ground. Okay, ground for vi greater than 0. Better to say when this one is positive. Okay, so when it is positive, okay, it is followed by, so it is sorted to 0. In simple word, means what we can say, this one is a ideal diode, or we can do like this one is some voltage. Okay, so transition voltage, during what time d1 will be conduct. Okay, so one can write transition voltage. There is a concept transition voltage. Okay, so this one is a vi plus or minus, so one can write vi minus, this should be ideal diode. So transition voltage when the diode is just on and the current is almost 0, so vi equals to 0. So okay, so in this case transition voltage is this one. Okay, vi equals to 0. So above this transition voltage, that will be conduct. So when it is conduct, this value will be 0 volt, so 0. And when it is not conduct, it will appear same as that of the negative voltage. So it will be better to explain like this. Okay. So this one will be the okay. So in my clipper video, it is already cleared so many numerical based on this concept. Okay, by using transition voltage. For more detail, you can also go from the Bolstead book. Okay, now another one, another question. In this question, what we have to do? Again, we have to draw the output response. Okay, so here V naught and T. Now, for any first half diode, either D1 will be conduct and D naught will be D1. Either D1 will conduct for positive half and D1 for the negative half. But when D1 is conduct, this value will be 0 volt. When for the negative half, it is conduct, so it is off, it is on. So again, it is connected to 0 volt. So every time the response will be 0 volt, 0 volt. Okay. So V peak plus will be 0 volt and V peak minus equals to 0 volt. Okay. The output will be always sorted to ground. So in this case, we can say the output voltage is always sorted to ground. So this is all about this problem. So one time this D1 is on, so again it is sorted. Okay, so this is connected to ground, so this is 0 volt. Okay, so this one will be the right waveform for this one, and for in this case you can use the concept transition voltage. So when it is diode is followed by for the positive half. Okay, so when it is followed by V naught will be 0, simply 0. So it will be 0. Okay, now for the negative half, it will open circuited. So V naught equals to Vi. In this case, V naught equals to Vi. Okay, so this is all about the problem, and this all problem are from the microelectronics circuit book. So thank you for watching this video.